and very good afternoon to everybody. I'm your host, Prashik Walke. Thank you for joining us for today's Payatu's webinar, DevSecOps 101 Integrating Security into DevOps. Before we get started, please let me take a few minutes to introduce Payatu. Payatu is research-powered cybersecurity consulting firm. We have decade-long track record with a singular focus on the cybersecurity. Payatu's impact is delivered every day through our three verticals. Number one, community and conference. Payatu runs hardware.io, a hardware security focused conference along with other initiatives. Number two, consulting and training. We primarily focus on offensive security assessments. Number three, products. Payatu has also released two products in a private beta trials, Exploity, firmware analysis framework, and CloudFuzz, an advanced fuzzing framework. This slide is an overview of various consulting assessments we execute for our customers across the globe. We have delivered talks and workshops worldwide in some of the top security conferences like Black Hat and DEFCON. This has been our decade-long impact to contribute to robust cybersecurity community in India and globally. Without further ado, let's get started with our webinar. Today's speaker, Nandhakumar, is a security consultant at Payatu. You can read about his wonderful accomplishments on this slide. Before I hand over to Nandhakumar, a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We will answer the questions during the few intervals or towards the end of the webinar. A recording will be released later via our LinkedIn page. So please make sure you are following Payatu on LinkedIn. Nandhakumar, over to you.
Sure. Let me share my pictures. So yeah. So hi everyone. So today's webinar is about DevSecOps. It's like I assume you guys are total beginner in this particular DevSecOps. So like I'm going to introduce about what is DevSecOps. Oh, I mean what is DevOps? Then like how can we integrate security into DevOps? Basically that is DevSecOps. So yeah. So I'm Nandhakumar. So in this today's webinar, like first we will see about what is traditional software development lifecycle, and then what is DevOps, and then what are the components in DevOps. Like there are various phases in that DevOps cycle. Then like what is the necessity of security in DevOps. Then why companies are moving from traditional DevOps to DevSecOps, and then what are the best ways we can implement security into existing DevOps pipeline. So what to expect from this webinar? Like we will see overview about software development lifecycle, and then introduction about DevOps, DevSecOps, all the things, and then like all the tools are there, and then like how can we practically implement DevSecOps, the existing pipeline. So yeah, so how the traditional software development lifecycle goes, there are 5-6 phases in that. First one is a requirement phase. In that requirement phase, we will gather all the requirement from that particular client. Like what are the things they wanted in that particular software, like that. Then second, it will be planning. In that planning, we will gather like from that requirement, we will analyze what are the things we need to do, and then what are the things we can protect. So first we will plan it, then we will design as a kind of architecture design, and then like we create a kind of prototype for the stuff. Then once we design that particular prototype, then we will develop the whole thing. Once we develop the whole thing, then we will do testing, like either unit testing, security testing, all the stuff. Once the whole thing done, like everything is patched, everything is working fine, then we will put those things into deployment. So what is the problem in the traditional software development lifecycle is there are various models in that. Like one is a waterfall model. In that waterfall model, like first we will do requirement analysis, then we will go to planning, then we will design it, then it will goes to software development, testing, and then deployment. But in the traditional waterfall model, like it will take so much time for developing a single thing. If suppose if the client comes to us and then asking us to like want to change something in their requirement, then like we need to repeat the same thing. So then they will. So because of these problems and all, like we are moving to DevSecOps. So DevSecOps, it's basically combining both software development and IT operation, everything in a single context. So the main core principle of a DevOps is automation. Like you need to automate everything rather than like doing everything repeatedly. I mean, manual task repeatedly. So it's completely following agile software development. So in the agile software development, what we will do. So first in the requirement phase, we will go to it, then we will plan it, then designing goes everything parallelly. If suppose one particular model design is completed, then we will go into development at the same time. Then for that particular model, we will start testing rather than waiting for everything to complete. So doing everything in a parallel way, so it will save the time. So we can complete the whole project as soon as possible. So it's following the same, DevOps following the same agile software development model. So it's mainly, as I said, automation is a core principle. So it will shorten the software development lifecycle timing, and then we can continuously deliver high quality software as soon as possible to the client. So there are a few glossaries before going to this DevOps thing. So first thing is pipeline, continuous integration, continuous development, and then artifacts. Pipeline is a kind of set of practices we will do at the time of development, at the time of operation. Like while building, testing, deploying the software, all those things, like we tell it this as a kind of pipeline. Then continuous integration. Integration in the sense, like as the name suggests, like we are integrating code into that particular artifacts as soon as that particular code, it's like the particular code is pushed into the GitHub or GitLab in software version control systems. So second, another one is continuous deployment. Once that particular continuous integration is completed, then we need to deploy that particular thing into the production environment. So it will continuously deploy the whole thing. So artifacts, basically in the sense like it's a deliverable object. For example, like you are developing a Java code. So Java code, like once you push the code, then like you need to compile that into WAR file and all. Then that particular WAR file is a kind of artifact. You are going to deploy that particular WAR file in Tomcat server or something. So this is a continuous deployment. So as soon as some small code or small changes in that, it will automatically integrate that particular code into that particular pipeline. Then it will create the artifacts. Then you are putting that particular artifacts into continuous deployment. So these are the essential components in DevOps. Like it's almost same like agile development. First we will plan it, then we will code it, then we will build it like var file or something. Then we will do unit testing using Selenium, JUnit, something like that. Then we will release that particular code. Then we will we'll put that particular thing into deployment server. Then we will operate in the sense like we create an environment which are the way it looks like using Kubernetes or Ansible stuff like that. Then we will monitor it, like if suppose log monitoring, all the stuff. So as I said in the planning phase, like we will check for we will plan all the things as per the client requirement. Then we will code it. Like since so much people are working on the same project, we use some version controls grid for that. Then like we push, the developer pushed all the code into GitHub. As soon as the Git commit happen, then this particular thing, it will start building automatically. So there will be a hook there. So it will automatically start running this particular pipeline. So as soon as the code committed, then it will automatically start building using Maven. Then once it's done, then we need to write, most probably like unit testing, it's already there. So it will automatically run it. Then it will check whether the whole thing is passed or not. Once the whole thing is passed, then we will release the code into production using Jenkins pipeline. Then like we will deploy those things either in a cloud services like AWS, Azure, all the stuff, or like you can use containers like Docker and all. So for creating the containers, all the stuff, or configuration management, you can use Ansible, Chef like that. Or like if you're going to use, Kubernetes pods for deploying all the stuff, then you can use that one also. So once it deployed, like you need to check the logs. Logs for like whether the whole thing is working perfectly or not. Like if some kind of kind of hack or something happened, then we can analyze the logs for that. So this whole thing happened in the whole DevOps pipeline. Then so this thing is going perfectly fine. So what is the necessity of security into the DevOps? DevOps, this particular pipeline. So security, nowadays, security is a kind of crucial part of the application and then customer privacy. Everyone requires secure. Everyone want to implement security in their pipeline in order to protect the customer's data. But what happened is DevOps, it's a kind of too fast. As I said, automation is the core principle. So like it's too fast for the traditional security. If suppose like what will happen in the DevOps, I say, like once the whole thing is deployed, then you need to go for some kind of consulting company. Then they will do either source code or like source code review, I mean white box testing or like gray box testing. It will take some time for doing all the stuff. Once they're done, then they need to put the whole thing to the I mean, they need to change everything in the code level, then they need to push it, then they need to recheck it one more time. So the manual vulnerability assessment, all the stuff, it creates a lag in this particular fast DevOps pipeline. So they want to implement something which will reduce that particular work. So that's why the DevSecOps model came in. So it has some obvious advantage over DevSecOps. So it will increase some automations. I mean, and then it will reduce bit about the manual labor, but it will not going to replace the whole pen testing, because the pen testing is something different. DevSecOps is something different. So it's not a pen testing one. So pen testing in the sense like what is the thing we will do in the pen testing projects and all, like we will search for all the vulnerabilities and then we will exploit it. But DevSecOps is basically they don't want to do the security as a kind of last part. They want to integrate that particular security into their existing pipeline itself, so that like it will reduce some some time for that to release that particular code. So we will going to see about it, how it is going to reduce the time, all the stuff. So next, so why the companies are moving from DevOps to DevSecOps? As I said, like security is a kind of it's like kind of no, like it's a kind of important thing nowadays world, like because so much breaches going on, everything happened. So like putting the security assessment at the end of the process, it will create a delay. Like if suppose there will be some model which that particular developer created, but that's not a kind of good one as per the security aspect. It's not much good. So what we're going to do is like we will like that particular developer then thinks like, okay, this model not going to work, then they need to recreate the same thing, and then it will create a lag, and then it created kind of delay for finding and fixing the vulnerabilities or the stuff. So we are going to induce that security into that particular DevOps model itself. So it will, basically DevOps in the sense like it's for automating the security audits, and then like we can reduce some fixes before it's going to the deployment stage. So it will also going to find security loophole in the application. Before it goes to outside the deployment. Yeah. So what are the ways we can implement security into the existing pipeline? There are 5 phases. So one is software component analysis. Second one is static application security testing, and then dynamic application security testing, and then OS hardening, and then container security, and then monitoring. So in the software component analysis part, so what we're going to do is like nowadays the modern application has so much open source and third-party components which may be vulnerable to some supply chain attacks. So in this particular phase, first we are going to check the framework libraries which we are using, whether it is vulnerable to any kind of vulnerability based on the versions, or like if it is a kind of outdated version, or like if it is a kind of there are some supply chain attacks happen nowadays, right? Like because of GitHub pages and all. So we are going to monitor all the stuff there, and then we are going to check for all the known vulnerabilities in the components. Anyways, like if you are going to use that particular libraries or framework which is already vulnerable, and then you use that particular code, particular module in your code, then it automatically inherits the risk of that particular vulnerability. So what we are going to do is, so we are going to check those things, whether it is a vulnerable or like whether it is a kind of best practice to use those things. Is it audible, right, guys?
Yes, we can hear.
So yeah. I guess some issue with Vinit. So in this one, like we are going to monitor the bugs in that particular library dependencies which you are using in the code. So that's the first step. Second one, we are going with static application security testing. So in the static application security testing, it's basically nothing but white box testing. So what we usually do in the white box testing is like we usually check for the application code, which is vulnerable for any kind of vulnerabilities or not, like SQL injection, XSS, XSE from the code level itself. And then it will also report insecure code practices like hard-coded secrets, keys, credentials in environment file or form.xml file like that. So basically the advantage of using SAST is like it will analyze the all parts of the code base rather than, so in dynamic part, like you are checking only the code which is externally like that particular functionality has some external support or something, API support or something like that, then only you can check those things. Internal part and all, you can check it from the dash. But SAST wise, since you have full access to the code and all, like you can check the whole code base to find the vulnerabilities. But as SAST only work on the code level, it usually detect the whole false positive, huge of false positive while running for the first time, because like it will not understand the logic behind what's going on there. So it will only check the code based on grep wise. Then it will find out vulnerabilities based on that, whatever the algorithm they are using. So at some cases, some manual tuning it will be required so that like it will not report huge false positive thing. So the second one is dynamic secure application security testing. So it's also a kind of black box or gray box. So it's mainly useful for finding vulnerabilities while at the time of runtime. So because staff only check application code wise, but it will not check all the vulnerabilities while at the time of running. So it will find out all the vast top 10 from RC to logical bypass, all the stuff. So it's completely independent of the application because like it's not from the code level as like SAST. So it will going to check all the vulnerabilities. I mean, independent of the application. So you don't need to go from code level and all. And then as said, it doesn't require any source code level access. So you don't need to use the source code to some third party vendors for testing the security of that particular vulnerability. So next one is kind of OS hardening and then container security. So yeah, before going to that, like we can implement DevSecOps here from the code level. Once that particular plan completed, then they started coding. So once that particular coding completed, before at the time of going to build, so what we are going to do, we are going to implement one more phase here. So it will first check source component analysis, whether they have any kind of dependency or any vulnerability, anything like that. Then once that particular part completed, then it will go to the next phase as task. So it will check for all the vulnerabilities at the source code level. So once that particular source code level completed, then anyways, it will going to report a few bugs or something. We are not going to block it from here itself. We are going to tell them to build that particular code. Once it built, then we will test it. Unit-wise testing is done. Once it releases, once it deployed, then here we will check DAST. So DAST in the sense like we will going to check at the time of runtime. So once it's going to deploy at some staging server or something, we are going to check for all the vulnerabilities. And then like it will find the whole thing. So once this one done, then that particular pipeline will end. So then the particular developer will going to, if you have integrate into like some centralized Jira or something like that, then that particular developer go into Jira and then he can check for all the vulnerabilities which is reported by either from source component analysis or like from SAST or from the DAST. So once they fix it, then they will push the code. Then it will run one more time. Then it will give you the updated report based on what's its fine and all. So say, as I said, DevSecOps is core principle is a kind of automation. This testing, it will not going to find all the bugs, and then it should not take more than an hour or so. Because like if it is taking more than an hour, like for example, you are mainly at the time of dash part. If it is taking all the parts in that particular dash, it will take huge lag at the time of pipeline. So this is the kind of thing which you need to do before going to kind of security audit. So that like security people, they will find out few bugs. Of course, they should find out. this will not going to find the whole thing, because as I said, dast and sast, it will report so much bug, and then it will miss so much bugs. So security testing, it's required, but it will remove few vulnerabilities like source code. I mean, some kind of source code leakage, or like sensitive credentials, or like leaking some keys or hard-coded passwords like that. So it will reduce few things, but it will not going to reduce the whole set. I mean, it will not going to replace the whole pen testing part. So yeah. So the next one is OS hardening or container security. It's suppose if you are going to put that particular deployment code in a kind of normal OS, or some container or something, it may also integrate the same vulnerabilities which is present in that particular host. So we are going to harden that particular OS or container if you're going to use it for enough for deploying our software there. So what most probably we will do, like we will push, we will pull that particular OS from Docker or something, base OS. Then we will harden it, and then like using AppArmor, SE Linux, or SE Comp, anything like that. Then we will put our code there, and then we will give only permission based on whatever things which is needed. So yeah, I'll explain. Most popularly used SE Linux. So SE Linux, it's like a mandatory access control security module based on the type enforcement. Type enforcement in the sense like, let's say example, like suppose if some application wants only open some file or read some files, search some file, get address or something like that, then like it will get it, whatever the policy which you are putting it there. Let's take example, you are running a browser or something. So what are the things which we needed? The browser, it requires internet access. Then it will require download access, or read and write access for uploading and then downloading file there. So you can create a policy based on that, what are the type enforcement you want to put it for that particular software. If suppose if you don't want to access, if you don't want to your browser to access your internal file system at that particular path to download that particular software or something, you can create a policy and then you can put it in the SE Linux, then it will work. So SE Linux, basically it's like a command line tool. I guess there are different tools for GUI also, but actually I forgot right now. So second one is AppArmor. AppArmor, it's same like SE Linux. It will do the same mandatory access control for accessing it, but in a different way. So for container security and all, like you can check for these things, these few points there. So where it is mounts, like suppose if you're going to mount the whole root system into that particular container, if suppose if that particular application has some vulnerability. So once that attacker get into that particular host, so what they'll do, they can able to access the whole files in that particular container which is mounted. So second one is a privilege container. So what are the capabilities that you're going to view? What are the privileges that you're going to view to that particular container? So what are the things he can with that particular container do it? So based on that, like you can reduce that particular privileges. Then associate within the container. Like it'll be better if suppose if you now like execute commands inside the container host itself using Docker exec or something like that, rather than port forwarding that SSH port or anything like that to outside world and then SSH directly into that. Why? Because like if you're opening some ports, so it will increase like attack vector size. So like you need to threat model according to that. So it will create some other problems also. So better we can just log into that particular host, then you can use Docker exec for executing any commands. So what are the ports which are going to bind it? So same like suppose if you're binding ports which is not not usable for outside and all, so better don't bind it. Same expose ports, like don't expose unwanted ports and all. Then run with some at least default SE Linux or AppArmor profile, at least default one. If you have something you want to put it based on your application, then yeah, put that one also. So using now and also avoid sharing host namespaces within that particular containers. So In the last phase, we need to monitor. Or I mean, like even the vast top 10, they put audit and login monitoring, all those things there. Why? Because once that some security breach or some incident happen, then it's like kind of important to get the data, like how they compromise and then what are the things compromised there. So it's kind of crucial parts for monitoring all the stuff. There are few things we are going to see about how can we use that ISAST or RAST to find the same monitoring things. But it at least you can put some SIM tools for monitoring all the logs, network flows on your applications on the particular host which you guys are using. So as I said, like it will going to be helpful at the time of forensic part. If suppose if you are going to, I mean, if some incident are happened, then like using those logs, they can check for all the insights, what's going on, and then you can check for the evidence to the compliance audit, all the stuff. So for this one, like you can use Elasticsearch or I mean, Elasticsearch is the best one. So you can use this Elasticsearch part. Then this is a kind of interactive application security testing. So as I said, fast, so it will check only the source code. And then because of that, it will create so much false positive because it will not understand the code, what's going on. Then last, it will only check outside it, kind of outside that particular application. Then it may create also some false positive based on the response which is coming, because I mean the applications are developed by so much developer with so much mindset. It's not much possible, no? Like for understanding the whole thing and then try to exploit it. So suppose if they implemented any kind of anti-automation things like capture or something, it's not possible for a dynamic testing tool to check those things, or like any CSR token or anything like that. It will be totally hard for doing that time. So it will be better if we use interactive application security testing. So it's like mainly this particular model comes mainly because it want to overcome some of the limitations of SAST and DAST. So in SAST, we will check from inside, and then DAST we will check from outside. So in interactive, I mean ISAST, we will check from inside out. So we are going to check the outside things, what are the things which you are testing, and then we will check inside also how it is implemented, all the things there. So I'll give you the example. Okay, so there is one application. So what you're going to do, you put on one agent inside. Okay, so what that particular agent will do, it will have the whole access to the network. What are the traffic coming? What are the requests you are sending from outside? And then it has access to DB also. What are the requests which that particular, I mean, at the same time, what are the access that particular DB, I mean, that particular that web application server trying to access from DB server, it has the whole command, and then it will map it based on that. So at the time of testing, what we will do, like if suppose if you're sending a SQL payload, let's take example as a SQL injection, okay? So if you're sending SQL injection, what normal web application or any tools, how it will detect, it basically depends upon the grab. Like, sorry. So it will check for that particular vulnerability using the grab-based model. So they have certain algorithms, and then they want to check it with whether these things are there or not. Based on that, if it is there, then it will report this as a kind of SQL injection attack, or this particular page is vulnerable to SQL injection, like that. So in interactive, what is the thing we will do? We will send a SQL request, and I mean SQL injection request. So it has the access to request also, and then database also. So first, what it will do, it will check the request, and then it will see like this is a kind of SQL injection, looks like that, and then it will take this as a kind of suspicious request, and then it will check for what is going on in the database. So basically, like if you're sending a normal SQL injection, what it will do in the database, it will execute it as a kind of expression, not as some kind of code. Let's take example, select a user from user table where ID equal to 1. So in that particular phase, that particular ID is a kind of string value. Normally it will goes like that way only. But in case of SQL injection, that particular request will be look like, instead of 1, it will be like a colon or colon, sorry, not colon, a single quotes or single quotes a, and then single quotes equal to, and then single quotes a. It looks like that kind of thing. So when it goes to, when this particular ISAS tool sees like this is a kind of expression. So basically, this is a kind of potentially SQL injection vulnerability. It will report that particular part. So it will think like, okay, this is a particular SQL injection vulnerability on this particular code. It will identify where is the code number and then like how that particular code looks like, all the stuff to the developer, so that they can easily, kind of rectify those things rather than dash like we simply report this is a kind of SQL injection vulnerability, not the line number or the things and all. So the next one is runtime application self-production. RF, it's same like ISAS. So what it will do, instead of this one reporting or something, it will monitor all the things and then it will report back. But what this will do, interactive application security, like while we are QA testing or something, then it will report it like kind of SQL injection or anything like that based on the code which you are doing. But what this will do, this will kind of monitor all the things which is coming out and in. Then it has some profile. It will check it like, okay, this is a SQL injection, happens like that, and then it will send a notification. So basically, this will not give what is going on, all the stuff where it is vulnerability, all the stuff, but at least it will report, okay, some SQL injection attack is going on. So SQL injection attack is going on that particular page, check it out like that. So that, for 0 days and all, nowadays, like it will happen because like we can't check it. Maybe they already did SAS, dash, all the things, but they can't, they can't find at the time since it's a 0 day or something. But when it comes to like code and all, then that particular things may be vulnerable for some reason. Then these kind of things can easily like monitor by using runtime application self-production. So yeah, so let me tell you like how this will look like. So the basically pipeline which will be going to look like, you are going to send a kind of the particular developer will commit the code. Once it committed, then it's already have a hook in that. Then it will do something like ISAST. Oh, sorry. The first thing is SEA. Then they will put it. They will build it, and then they will do all SE Linux or Jenkins, all the stuff. JUnit, all the stuff. Once the whole unit testing completed, then they will release it. Once it will deploy, they already have ISAST in place, and then they will check it. What are the things there, and then what are the vulnerabilities there, combining both SAS and DAS. Then they will report it. Then they will patch it till the times. Once the whole thing completed, then they will put it in a kind of staging server or something. Then once they put it in the staging server, then they can give access to testers. They want to check for vulnerability analysis or penetration testing. Once the whole thing completed, they will do the same thing. Based on the reports, they will try to check the whole thing. Once the whole thing completed, then they will put it into kind of development. Most of the times, what we are saying is like, till this point, CI point, they will give access to the production. Most of the times, the production part will be manual kind of thing for security reasons, because like if suppose this particular pipeline is compromised. So what is the thing that particular attacker will do? That attacker have whole access to all the things in the production environment also. So most of the times production part, they will not do it, but they will do in the testing part. So that's all for this presentation. Anyone have any questions?
Guys, if anyone has any question, you can ask in the chat.
Hi guys, my name is Bek. I have a question.
Yeah.
Where do we start the threat modeling in this pipeline? Any can help me out to understand that?
I don't get it. Where do you want to start in the
Well, yeah, well, let's say we have threat modeling, right?
Yeah.
So generally in SDLC, it starts at the design level. So when it comes to this, DevOps pipeline, so where exactly we are starting that modeling, and which tools will help in this process?
Okay. So for threat modeling, I think it's not possible for automating all the stuff. It should go with a manual thing. Like I feel like you can go for like vast they have SEA tools, different SEA tools. Mainly it's completely depends upon the code. You can't use this particular tool on this particular page. But vast they have it for Java, vast I guess SEA I guess. So you can check that one. Then for source code analysis and all for SaaS part, you can use FindSec bug, or like you can use check marks, or like or different ones. I mean, it completely depends. Same as that. For DAST and all, you can use Aquantex. I mean, Aquantex, it will check for the whole sort of vulnerability. So you can create a profile as that, like you can't run a single scan for 3 hours, 4 hours. It will totally kind of, I mean, it will not going to automate the whole thing. So you can check for only different vulnerabilities. Otherwise, you can run Nikto, or like you can use WAS, ZOP, or Babsuit for finding the critical bugs. So for the whole automation thing, you can learn Jenkins. Jenkins, it's completely useful for CI/CD pipelines. It's basically totally easy. So like it's like just like kind of click. There is one Jenkins file there. You can create a pipeline based on whatever the commands you want to run. And then they have the plugins also. So in that plugins, like if you want to integrate some different tools into Jenkins, they already have a plugin. You simply download the plugin and then simply give what are the things which is required, then it will automatically take care of it.
Okay, thank you.
Start learning. For Subham, like you first start with, I would say start with DevOps and then try to understand the DevOps culture. Like, I mean, what are the things there, and then like how can we integrate all the stuff there. Once you know the DevOps, then DevSecOps is nothing. Like you can integrate few more tools into the existing DevOps pipeline. So yeah, start with DevOps and then all the things there. And then there is one GitHub link there. Maybe I can show you guys. Mm. Mm. And this one. No, not this one. Yeah, this is the one. So you can have the labs. Yes, this one bootcamp. So basically this is a kind of DevSecOps bootcamp. So you can learn more from this one also. I'll put this link in the chat. You can check it out. And anyone else? Okay.
We can wait 2-3 more minutes if anyone has any question. Yes, slides we will be sharing. We will also sharing the recording on our YouTube channel and on LinkedIn page. So please follow us there. Guys, please ask if anyone has any question. Otherwise, we can go ahead and conclude the call. I think no one has any questions. So thanks, Nandhakumar, for delivering such wonderful webinar. Thanks to all participants for being so attentive. We'll be sharing the webinar recording on our LinkedIn page. So make sure you follow us on LinkedIn and also follow us on YouTube as well. Thanks again.